Kia ora. So far we've been looking at solving linear simultaneous equations. We're now going to move on to solving nonlinear simultaneous equations, which is the focus of Achievement Standard 2.14. Intersection of a line and a parabola. Example. Find the point or points of intersection of a line A, y equals 4 minus 2x, and the curve B, y equals x squared minus 5x minus 6. Because both of the equations are given in terms of y, it makes sense to set them equal to each other, or equate them. This gives us x squared minus 5x minus 6 equals 4 minus 2x. Our next step would be to move all of the terms over to the left-hand side and therefore set the equation equal to 0. In doing so, this would simplify to x squared minus 3x minus 10 is equal to 0. At this point, we would then look to factorise it, thinking what two numbers multiply together to give negative 10, but add together to give negative 3. We should find the factorised form to be x minus 5 times by x plus 2 in brackets is equal to 0. So that means that either x minus 5 is equal to 0 or x plus 2 is equal to 0, thus giving the solutions for x as 5 or negative 2. With each of those x values, we can then work out the corresponding y value by using either equation, but it would be easier to use A. In doing so, when you substitute x equals 5, you'll get y equals 4 minus 2 times 5, which is equal to negative 6. Substituting x equals negative 2 into the equation, y equals 4 minus 2 times negative 2, which would give you 8. So the solution points would be 5, negative 6 and negative 2, 8. Note that this could also be solved by graphing. In looking at the graph, you can see how powerful it is, and this highlights the two solution points that we've just solved. I strongly recommend when solving these equations to simply sketch a happy face parabola and a negative sloping line to be able to visualize exactly what it is we're looking at solving. Finding the intersections of lines and curves. It is best to use the substitution method or graphical methods. So it usually results in a quadratic which has two solutions because there's 2 points of intersection. You could have a situation where there's just one solution or one intersection point, and that line there is known as the tangent line. Or you could have no solutions, and that's because the curve and the line are not intersecting. Please go now to page 471, exercise 29.01 in the new textbook, and look at questions 5, 7, 9 onwards, or find the equivalent in the old theta textbook, which I've referenced in our lesson outline.